Hey everybody, this is Mr. Palacios coming to you live from room number 5, and I'm going to be going over some information today. We're going to be looking at geometric sequences, and we want to figure out how can we write a rule for a geometric sequence. But first, before we can do that, we got to figure out what in the world is a geometric sequence, and so that's what I have my handy dandy notebook in here for. Why don't we get rid of this? We're not allowed to, it doesn't let us. Well, really quickly, a geometric sequence is just a ratio of consecutive terms, okay? And ratios we usually write as like x to y, or x to y, or x to y. For every one of these, there's that many of, for every x, there's that many y's, okay? So it's just a ratio of consecutive terms, and we'll see what that means. And if the constant ratio is called the common ratio, how much is everything growing by, right? So if we had x to y, and then we had 2x to 2y, we want to see how much everything is growing, what that constant ratio is, all right? And we'll start off by going back in time to ancient Japan. And in ancient Japan, the makers of swords in the 1400s repeatedly folded and hammered the metal to form layers. So they just folded metal upon metal upon metal. The folding process increased the strength of the sword, so they did that because it made their metal stronger. The table shows how the number of layers depends on the number of folds. We need to write a recursive rule, so a rule that tells us how much everything grows by, and an explicit rule for the geometric sequence described by the table. So if we look at this table, we have n, that's the number of folds, and then the number of layers. So how many folds gives us how many layers? Well, when we have one fold, we have 2 layers, right? If you just took a piece of paper, if I took this piece of paper and I folded it in half, ta-da, I have one fold, and now I have 2 layers. If I fold that again, I have 2 folds and 4 layers, okay? And then if I fold that again, I have 3 folds, and then there's 8 layers in there. If you could count that, you would see that there's 8 layers right there, right? And then if you do this, all of a sudden the paper disappears. How did I do that? All right, well, as you grow up the number of folds, you also grow up how many layers are. You go 2, 4, 8, 16, 32. 1, 2, 3, 4, 5. So you can see as we grow by 1 on our n value, we grow by double on our function of n value. Okay, and that repeats every time. So we need to find the common ratio and to calculate by calculating the ratio of consecutive terms. So we have 4 over 2. We always want to put our y over our x, or a function over our n, right? Function of n over n. Whatever our function of whatever over whatever that letter is. So we're going to put 4 over 2, and that equals 2. And then 8 over 4, that's going to be 2 over 1. Let's just simplify, right? 8 over 4, that's going to reduce to 2 over 1. 16 over 8, that's going to go 2 over 1. And then 32 over 16, that's going to give us a ratio of 2 over 1. So the common ratio, R, is 2 over 1. Easy. Easy peasy. Sorry, I'm going up to B now. Okay, I'm going to erase these. If you didn't get them, go back over that, review it, rewind it, and you'll get it. All right, so we're going to write the recursive rule for the sequence. Okay, the first term that we have, if we look back here, for n, if we have one n, we have our function of n equals 2. Okay, so that's going to be 2. The first term is 2. Okay, and this is going to be 2. The function of n for 1 equals 2. Okay, and then what we're going to see is that every time that we go up 1, so when we have 2, 3, 4, we go up 2, 4, 8. And so what we're really doing is, I'm just going to put this right here. That way I don't have to keep moving up and down. Okay, we're going to say whatever we got previously, so for n minus 1, we're going to multiply that by 2. Okay, and you can see that here. So whatever we had got previously, we're going to multiply that by 2. Okay, same thing here. So for 4, we're going to take whatever we got previously and multiply that by 2. That's what this is saying. N minus 1, okay? We're not saying 3 times 2. We're saying what we got for the answer for our function, 4, when we have 4, we want to see what we got our previous time, which is 8, and we're going to multiply that by 2. And you can do that anywhere on the number line. If we had 6, we would take whatever we got previously, 32, that's what n minus 1 is. Whatever our function's answer was previously, we're going to multiply that by 2, 64, right? And then you can use that to basically find out how many layers of metal there would be on any given fold. Okay, I'm going to scroll up again. And what I'm going to do is I'm just going to take this page by page and make each video one page, and then, or at least one section, and then we'll go from there. Okay, so this was n minus 1 times 2. So every other term is the product of the previous term and the common ratio, which is 2, right? The previous term and the common ratio. So you're going to be creating rules that are like that, recursive rules that tell us how to find out the value given a function, a number to plug in, and given the previous answers for that function, the previous products of that function. All right, so here we have, for when n equals 1, we have the function of n equals 2 times 2 to the 0 power. 2 to the 0 power is just 1, right? Anything to the 0 power is 1. 2 times 1 is 2. Okay, here, this is our explicit rule, right? So when n is 2, we have 2 to the first power times 2. 2 to the first power is 2. 2 times 2 is 4. For 3, we're going to put 2 to the second power. Okay, again, the previous term. So 2 times 2 is 4. 4 times 2 is 8, right? And we got 4, if we look back here. 4, right? So when it was 3, we looked at the previous number, and that's how we got our function, all right, our answer. So here when n is 4, we have 2 to the third power, or 2 times 2 times 2, which is 8, times 2, which is 16. And now for 5, it's going to be 2 to the fourth power times 2, that's going to be 32. When we're doing this, notice that 2 times 2 to the fourth power is really just 2 to the fifth power. But the reason that you can't just put 2 to the first power, or 2 to the second power, or 2 to the third power, is because at some point you're going to, if n was 0, then this would be 2 to the 0 power, and that would equal 1. And that's not what would happen. That's not how many layers you would have if you had 1 fold, or if you had 0 folds. Right? Anyways, that's that. So the generalizer results for the table, the function of n equals 2 times 2 to the n minus 1 power. That's all that this is saying. All right, so let's reflect really quickly. Explain how you know that the sequence 4, so these are completely different numbers, 4, 12, 36, 108, 33, 40, 24 is a geometric sequence. Okay, well, we can see that 4 grows 3 times to get to 12. 12 grows 3 times to get to 36. 36 grows 3 times to get to 108, and so the pattern grows by 3 times the number. Right? So it grows by the same multiple every time. 3 times the number, or 3 times n. Okay? A geometric sequence has a common ratio of 5. If you know that the 6th term of the sequence is 30, how can you find the 7th term? All right, so that means that we have n, and then the next one is n times 5, and then the next one is n times 5 times 5, and then the next one after that is 5 times. Okay, and so we're just growing. But we don't need all this because we know that on the 6th term, so 1, 2, 3, 4, I don't even want to try the next one. We'll just do 30, okay? We could also find the previous term given that the common ratio is 5. But we know that if the 6th term is 30, all we need to do here is for our 7th term, get 30 times 5, right? Or 150, and that's going to give us our 7th term. Okay, so how would we find the 7th term? Multiply 30 times 5. That's going to give us the answer. All right, I'm going to pause right there, give you a chance to go back if you need to, just review what we talked about, and then we'll go on to number 2, explore, and we will be mostly done with this lesson. All right, talk to you guys later. Peace.